kind of simplify this from homework 25, number 48. So the key here, I think, is to look at square root as an exponent. So what is the square root as an exponent?
1/2.
Yeah. And now when you raise a power to a power, what's our rule here? And so the 2 times a half will be cancel, and we'll just get e to the x. So it actually simplifies to be e to the x.
Okay, pretty easy.
Yeah.
Can we do 46?
46?
On homework 25 as well.
Okay. Do you know what that is, or
I don't.
do you know what page that's on by chance?
185.
185.
Yeah, that sounds right.
I know, I thought it was gonna be so cool today.
I'm a sweater and a sweatshirt.
Oh, yes, a bunch of square roots there.
Yeah, it sounds 185.
Okay, so we have any glasses for this one? So we have the square root of 6s squared t cubed b to the 5th. And then that's going to be times the square root of 6s t to the 5th and v to the 3rd. Like that. Okay, so there's a couple ways you can do it. We could simplify each of these radicals first and then multiply the insides. I don't think any of the multiplication there is really daunting, so it might be easier to just multiply those. So that is the square root of a times the square root of b is the square root of a times b. You can multiply their insides. So if we do that, then we're going to get a 36, and we'll add the exponents and get s to the 3rd. You with me there? And then we'll add the exponents and get t to the 8th, and add the exponents and get v to the 8th. Now, from here, we can break this apart. And so we're taking the square root of each of these things. So the square root of a product, we can go the other direction. We can make that the product of the square roots. So the square root of 36 is going to be just 6. Now, the square root of s to the 3rd, there's kind of different ways you can think of it. You can look at it as being s to the 3rd is s squared times s. And then we can say the square root of s squared is going to be just s outside the radical. Okay. So then we're going to pull an s out, but we'll leave the other s inside. Now the t to the 8th, you can think of, I mean, there's a couple ways. You could think of it, since you have an even power, it's nice to think of that square root as 2 to the 1/2. And so you're just going to divide the exponent by 2. And so that's going to come outside then as t to the 4th. I mean, you could, I think it's a little tedious, you can break it down into, a bunch of t squareds. So the t to the 8th you can break down there, and then it's going to be t times t times t times t. So that's okay. I just think it's kind of inefficient that way. If you kind of get the hang of it, you can also, looking back at the s to the 3rd, if you wanted to, and I don't know that this is really a great way to think of this, but you can kind of think of it as 3/2 as being 1/2, where or that's an s rather. So the 3/2 as being 1/2, where that's the s to the 1st times the s to the 1/2. That's how we got the s outside, but the other one is still inside. That kind of makes sense. And then we'll get the v to the 4th will come outside as well. And so the only thing that's still stuck inside that radical is that extra s. And so that'll be our result. Okay. Anything else from homeworks? Yeah, Emma?
Can we go over 17 on homework 26?
You know what that is, or do I need to go look that up?
I don't know.
Okay, so I think this is from graphing assignments. So, page would that be? Number 17, so I think we're on page 162. And let me see what we got here. So we have f of x is 1/3 of the x, does that sound right?
Yeah.
And g of x is 1/3 to the x plus 4 power. And h of x is going to be 1/3 to the x minus 2 power. And how do the graphs compare to the graph of f of x? So we want to know how do g and h compare to the graph of f of x. So, and we don't really have to graph these because they just want us to compare, but I think it's kind of nice to see it. So if we remember how do this one in green? So because this is less than 1, the 1/3 is less than 1, is this going to be growth or decay? And so decay we know is going to do this falling from left to right. So here is our kind of comparison function. Now when we do this, if you remember what this x plus 4 does in general, this is what they're trying to get at here. So if you had something you're more familiar with, a parabola that was, you know what y equals x squared looks like. And what would the x plus 4 squared do?
Change the y-intercept?
That's actually not, well, indirectly it will. So if we had, so just as an aside, you know, we're going to pick a function we're more familiar with, because I think y equals x squared we have a pretty good understanding of. Then if we did x plus 4 squared, what does that x plus 4 do to that vertex? Is it going to move it right, left, up, or down?
Move left.
Left. Okay? So that's a rule that's universal for all graphs. So when you look at this one, the g of x compared to the f of x, because that x plus 4 is up there by the x, that is going to move this 4 to the left. And so that's what they're looking for. You can just say those words. You know, we would see that this point that was at 0, 1 is going to now be over here at -4, 1. And then it's going to still have that same shape, that exponential decay shape, because of the base being 1/3. And then similarly, if we have this x minus 2, what's that rule?
Just gonna move it 2 to the right.
2 to the right. And so if you kind of just pick out one point to kind of keep track of, that point that was at 0, 1 will go to 2, 1. And then we're going to still try to have that same exponential decay shape that we did for the original 1/3 to the x. You could have just, to answer the question, you could have just said the words. This is going to get moved 4 to the left, this is going to get moved 2 to the right. And that's the visual. What else? Okay, so we're going to talk then today about compound interest. So we will make a lot of use of our graphing calculator today, which will be a challenge for me on the video, but we'll see what we can do. So 4.4, this is going to be applications of compound interest. So we want to first kind of get familiar a little bit with the formula that we're going to use, and we have some language, vocabulary that goes with this that's kind of specialized. So our compound interest formula is going to be A equals P times 1 plus R over N raised to the MT. So in this formula, this, you know, is our amount, is what that's supposed to represent. That A is supposed to be the amount after T, whatever the time is measured in. Usually that's going to be in years, but not 100% of the time. So we have to be a little open and make sure we check within the context of the problem. The P is, again, so at T0, we still have this very complicated looking base, but raised to the 0 power is going to still just be 1. So P is still what we call our initial amount. And because a lot of times the examples that we use this in come from money and investments, but not again 100% of the time. So a lot of times that is referred to as the principal, which when you are borrowing money or investing money refers to the initial amount. So it's just another name for the initial amount. This R is going to be our interest rate. So again, the R implying that rate, the interest rate. And usually that's going to be it's an annual. We're going to talk about this a little bit more, about what we mean by the nominal interest rate and the effective interest rate. And then this N, which is the same in both places, is going to be, that's the number of times we compound that interest. Number of times, usually per year, interest is compounded. So the typical numbers we use for N are going to be 1 if we just compound it once per year. Sometimes it'll be quarterly, so the N can be 4. Monthly would mean it's going to be compounded 12 times. And then daily, we'll consider that to be 365. Although there's some discussion, do banks use 360 or 365? Usually it won't make a big enough difference anyway, because it's once you get up to numbers that big, there's not a huge difference, but we'll use 365. And then the T is going to be our time. So the T is in time, and usually that's going to be in years, although, like I said, not 100% of the time. Okay? So has anybody not seen this before? You've all done this before. So we're reviewing, but we're going to take it to probably a little bit deeper level than maybe you did in your Algebra 2 experience. Can I erase this then, and I'll rewrite the formula so I can have this board space? So I'm going to put it up here so we can still reference it. So A is going to be P times 1 plus R over N raised to the NT. So suppose 12% interest compounded annually. So when we say compounded annually, that means once per year. And then we're going to compare and contrast that to 12% interest compounded monthly. So in particular, we'll just look at what we're going to get. What's the return going to be? How much are we going to earn? What will our balance be, our amount be after that 1 year? So we're just going to choose 1 year as our time increment and see what happens. And suppose we're investing, say, $1,000. So we're going to take $1,000, we're going to invest it for 1 year, and then we're going to see what do we have at the end of that 1 year given these two different returns. So on the first one, we're going to get A is going to be the 1,000, that's our P. So the 1,000 goes in where the P is. We're going to have 1 plus, and the R, because that is at 12%, has to be converted to a decimal. So the 12% is going to become
1.12.
That's what we're going to ultimately get, but I'm going to say 0.12 for now, just so we can see where everything goes. You're fine. You can just jump to that. And the N, the number of times we're going to compound it, in this case, in the compounded annually scenario, is going to be just the 1. And so that's going to be then the N here is the 1, and the time is going to be 1. So as Nora was saying, and you're welcome to jump to this, that's going to be 1,000 times 1.12. And when you multiply by 1,000, we're going to move that decimal over 3 times. I don't think we really even have to have a calculator there. So I think that's going to be, what, $1,120. I'll just leave it like that. So the 12% interest means we have increased our money, our investments by that $120. That's the 12%. Now the difference on the compounding monthly is we're gonna again start with that $1,000 is our P. We still have the 1 plus. The interest rate is still 12%, so we're still making that into a 0.12. But now what we do is, in effect what we do is we take that 12% that we were going to pay out over the entire year, and we divide it by the number of times we're going to compound it. So dividing that by 12 is going to really make that be just 0.01, 0.01, I believe, right? So we're going to, in effect, we're going to pay out 1%, but then we're going to do that every month. So the 12% we were going to distribute over the entire year, instead of waiting till the end of the year, we're going to, after the first month, get 1/12 of our 12%. So 1%, we'll put that into your balance. Then the next month, that little bit of interest you earn the first month will get a chance to earn interest. And so you're accumulating interest as you go, which then increases that balance, that amount, that principal, that amount that's actually going to earn interest. So that then is going to be raised to the 12 times 1, so that's to the 12th power. So we end up putting into our calculator 1,000 times 1.01 to the 12th. So it's this number right here that's going to end up turning out to be bigger than that 1.12 that we got there. And that's the power of the compounding. And so what did you get for that? 1,000.
126.
126 and what is it? 83 cents when you're round to the nearest penny. Okay, so you can see that this compounding ended up with a larger result. So we gained an extra $6.83. So we gained an extra $6.83 just from that fact that it was compounded monthly rather than annually. So what happens is, you see, we're getting a different return on this. You know, we say in both cases we're getting 12% interest, but in fact, you know, in the compounding annually, we did earn 12% in that first year. But in the next year, our balance will have increased, and so we will gain more than the $120 we did the first time. So that too is going to increase. And here, because of the compounding monthly, we got a higher return. So these have names, how we can distinguish this. What do we mean? Are we talking about what we say the interest is, or what the actual return is, what the actual percent increase is after all that compounding is done in the course of a year? And so the 12% we say is what's called the nominal interest rate. So these are some words that you will hear. So we say 12% is the nominal annual rate. Or sometimes we just call it the nominal rate and understand that we mean that's per year. So nominal actually means, nominal means in name only. So that nominal rate isn't really going to be, most of the time, the actual rate of return, or what we will call the effective annual rate. So we say the effective annual rate, or sometimes we just call it the effective rate again, leaving out the annual part, but understanding that we mean per year. And in the United States, this effective rate is called the APR. And the APR stands for the annual percentage rate. So you see this, like if you've ever seen a credit card application, you know, they'll, try to promote whatever it is they're trying to get you to and then in a really tiny print on the bottom, they'll tell you what the APR is. So credit cards charge monthly interest. So that when you're effectively borrowing something when you use your credit card, and so when you pay it back, you are paying interest that is compounded monthly. And so they will say, whatever their rate is, and then in a really fine print, they'll have to say, what is that in an annual rate, the effective rate there. So what we do, when we're finding the effective rate, what we're really doing is kind of like what we saw here. We can really, I'm going to say, to find the effective rate, because that's what I'm going to ask you to do here in a minute. To find the effective rate, given a particular nominal rate, we can really sort of just ignore the P and the N, I'm sorry, the P and the T, and just look at what are we going to multiply that principal by in 1 year with that 1 plus R over N to the N. Or if you want, you can think of it as being, let's just say P is 1, so we're not going to worry about that. And we're going to let T be 1 because we want to know how much we're going to pay or earn, depending if it's something you're borrowing, a loan, or an investment. So we'll just look at that part of it, the 1 plus R over N to the N. That's going to give us, that will be converted then into some kind of 1 plus R. And notice that that is what's going to be multiplying this principal, that amount that we started with. So whatever this 1 plus R over N to the N turns out to be on our calculator is going to hold in it there, that number, that thing, that factor that we're multiplying by is going to be our 1 plus R. And so we can pick out from there then what that R is. That's going to be our effective annual rate when we change that to a percent. Okay, so here's an example. So let's say, what is the effective annual rate? So what is the effective annual rate of an investment that pays 6% per year, compounded daily? Make sense what we're going to do? So help me out. So how are we going to figure this out? Grace, can you walk us through this?
So I think that we would start by writing it into the equation.
Okay.
1 plus 0.06 over 365.
Good.
To the 365.
Exactly. And what are we going to do after we throw this on a calculator? That's exactly right. And once we do that, then we're going to think of that as being 1 plus R. And then we're going to try to figure out what is that R. And our answer should then be as a percent. That's exactly right. Okay? So I'll let you do that. Get it, Emma? What you get?
Actually, I don't think I did it right.
Tell me what you did. Did you plug this into your calculator?
Yeah.
Okay, what did you get?
I didn't put it to the power of 365.
You need to do that then. So put it to the power of 365. You can just take the answer that you just had. So if you just up arrow highlight that and then go raise to the 365, that'll still work. What'd you get?
Where's the up and
We gotta get our calculator skill.
What did you get?
Let me see what you got. Okay, that's good. So
And
then
then the actual like
so
rate
go
percentage.
Zero here. Oh, sorry. Well, that works too. That works.
1 plus R equals that,
Oh.
and then you say
Mhm.
minus 1, and then you convert it to a percentage,
Yeah,
right?
just for future
It'd
reference.
just be like
So use this
6.199.
arrow, and go up until this one's highlighted.
I got
Hit this arrow right
6.183%.
here,
Yeah.
hit enter.
Is that what you got?
So it'll capture
Yeah.
that when you play. And you can also now do your
Why
upgrades to
don't
the
you put that to
365.
Because 1 plus R equals 1.06, whatever.
That makes
And you
sense?
take away
Okay.
1.
So now, what did you get then for the R?
and then it has to be a percentage.
Oh.
Got it.
What'd you get, Emma?
1.06.
So you get 1.06, give me a couple more. 6.
180.
Okay, so now this is our 1 plus R. So you're subtracting off the 1. Now you got 0.06183. Now make that into a percent.
6%.
I was hoping for a little bit more in terms of decimals, yes. No, I don't know what I did. Oh, I know what I did. Okay. It's all right, I think I'm back. Okay, so let's change the problem. Put a new twist on it here. And let's ask, if you invest P dollars, so if you invest P dollars, we don't really know, we don't have a number for that, at 4% per year, 4% per year, so that's our nominal rate, compounded quarterly, by what factor does P grow? By what factor does P grow? So we gotta decipher what this is asking us. What do we know? What are we being asked here? So we don't know how much we have to start with. We're just gonna call it P dollars. We're gonna have 4% per year. This is our annual interest rate, but that's just the nominal rate. That's not really what we're gonna get because we're gonna compound it quarterly. And then what's this? What do we mean by a factor?
1 plus R.
Yeah, so what do we multiply the P by? So a factor is, two things are factors when they multiply, right? 5 times X, 5 is a factor, X is a factor because they multiply each other. So in our P times 1 plus R over N to the NT, we want to know what is going to multiply that P. So we're trying to figure out what is that 1 plus R over N to the N. So it is going to be exactly a 1 plus R. So it will hold in there our effective annual rate. Know what we're doing? Do it. See if I can pause this right without scooping things up like I did here. I didn't finish my question. By what factor does P grow, I'm going to say, in 5 years? Aha. Yeah, that changes everything. So now we do want to include that T in there in our factor. And the next question I'm gonna ask, once we get the factor thing figured out, is by what percent did it, meaning the investment, grow in that 5 years? So first I want the factor. So that's like what we talked about here. What's multiplying that P? That's gonna have that 1 plus R in it. And then after we figure out what that factor is, what that 1 plus R is, then can we say from looking at that, by what percent did that grow in 5 years? And notice, getting 4% per year for 5 years when you got compounding, it will not be 20% growth. It's not going to be just 4 times 5%. Okay, so Ashton, what did you get for your factor? What did you get for this 1 plus 0.06 over, we compounding it quarterly,
0.04.
0.04, I guess that'll
Oh
make
my
a difference.
God.
Momentary pain of there. 0.0, and then we're gonna go 4 times 5, so that's gonna be to the 20. So what did you get there?
1.22.
0.19, thank you for reading my mind like that, Nora, I appreciate that. So that's our factor, okay? Did anybody not get that? Anybody not get that? Okay, so then keep going with it, Ashland. So by what percent did it grow in that 5 years?
No idea.
No idea. Who can help us? Ronan Norris, carrying the whole class, I think here.
22.0.
Yeah. So this holds, remember that the thing we're multiplying by holds the R in it. How much bigger than 1, or if it's decreasing, how much less than 1. And so if you subtract out that R, or that 1 rather, you're going to get 0.22019. So that is the percent growth over that 5 years. So it's 22.019% growth. So notice, it's not simple multiplication. It's not that you got 4% every year for 5 years, so therefore 4 times 5 is 20%. No, you got more than that because of the compounding that's taking place. Okay, good. Let's ask another question. Okay, let's say this time investment growth decreases. Add investment. Investment decreases by 75% over a 10-year period. What's that?
Decreases by 75%.
Yeah, not good, huh? It's almost like you invested in, I don't know what's been killed by COVID that you can't do, I guess, you invested maybe in travel, yes, or something like that. And
Vacationing.
yeah, anything vacationing is hurting right now. So over a 10-year period, it could be 6-month period in our case, yes. So by what effective annual percent did it decrease? Now you got to think about what this really means. The investment decreases by 75% over a 10-year period. Wow. Wouldn't it just be 75 divided by 10, 7.5%? No, because it's compounding again. What's that?
The 10th root of 75?
Well, let's think about this a bit now. So here's our formula we're going to use, and let's see what we know and what we're going to put where. So do we know how much we started with? No. So I guess we'll just leave that for now as P. Now here's the first tricky part. If it decreased by 75%, what do we have after that 10-year period?
A quarter of P.
If we lost 75%, we still have 25% of what we started with. So what we have is 25% of the P. And 25% of the P, we're going to write as 0.25P. Okay, that's the trickiest part of this, not that there's not other tricky parts. Okay, so now what do we get? We have 1, I got that part, plus What are we gonna use for R?
Negative 0.75 or
What is it we're trying, maybe we should back up. What is it we're trying to find?
The effective annual rate.
Effective annual rates, right. So that means we're trying to figure out what percent are we going to be decreasing by each year. So if we want the percent that it's going to decrease by each year, we want to use R as that percent we're looking for. And what will we use for the N?
R?
1, because it's percent per year. So we're now, that's really meaning we're compounding this just once a year. Okay, so that's going to be R over 1. And that means we're going to go, N is going to be 1, and what's the T?
10.
There's the 10. Okay? You figure out how to solve that? I'll give you a moment. So we decided that we could divide out the p's and get the 0.25 is equal to 1 plus r to the 10th. To solve for this, we want to get rid of this 10th. So we could take the 10th root of both sides, or we could raise both sides to the 1/10 power, which I think is a little bit easier to do on your calculator. So then we're going to get to the 1 plus r, which is what we want, is equal to, and Emma, what did you get when you took 0.25 to the 1/10 power? Is that right?
5505.
So do you,
5 times, okay, we're agreeing there?
yeah.
8705 or whatever, something like that. Okay? Okay, so then what do we do there?
Subtract 1.
Subtract 1. So, what'd you get there? Nora, can you read off what you got?
Negative 0.12944494.
All right, so that, and so this then means what?
That is the percentage decreasing.
That's
Well,
not the percentage.
almost, not to make it a percent, which was what we want, we're going to say,
Multiply by
yeah, so 12 points, we go 945%. And this is a decrease. So I don't care if you say a negative 12.945% or if you say it decreases by, and then you wouldn't say the negative there. Okay, per year. That's the effective annual percent decrease. So you're losing money at about 13% per year. Over 10 years, that results in you losing 75% of what you started with. Okay, let's try a different one. Let's do, if you need $100,000 in 30 years, who among us doesn't? If you need $100,000 in 30 years, what is the minimum amount? What is the minimum amount you should invest at 4% annual interest compounded monthly? If you need $100,000 in 30 years, what's the minimum amount you should invest at 4% annual interest compounded monthly? So we're gonna plug in where? Should we talk about it, or do you need a moment to think?
Plug in 100,000 for A.
Okay, hold on. So 100,000 goes in for the A, because that's what we want the amount to be.
And we don't know P.
We don't know the P, that's what we're trying to find here. So we're gonna leave that as just the variable P, but that's what we're gonna try to eventually solve for. Okay, keep going.
And then 1 plus 0.04 or 12,
Nice. And then that's gonna be raised to the
360.
30 times 12.
30 times 12. Very nice. So I'm gonna write it as 30 times 12, but you're right, we're gonna put that in as 360, or we can, I think in the newer calculators, you can actually put it in there that way. In the older ones, that would be a problem. Okay, gonna give it a shot. I'm gonna pause it for a moment, so we can do that as one entry. No, I'm doing there, Emma. Can you do that? 100,000. You can divide by, and good. But then you need parentheses. Let's back up. So just go left arrow. Right there, make it overtype. 0.04 divided by
What'd you get?
12.
You should invest $30,179.54.
Okay, so Ronan, what'd you get?
I got $30,179.59.
You have confirmation on that? Anybody else agree with that?
Yes.
Okay, you got the 2 thumbs up. Emma, did we get that too? All right. Emma agrees it must be so. So let's do another one. Let's ask this time. If you have $10,000 to invest, if you have $10,000 to invest, and you would like $50,000 in 25 years, not quite next week, but in 25 years, what should your effective annual yield be? Effective annual yield be. Okay, think about, we'll give everybody a chance to chew on this for a little bit, but think about what you know and what you're looking for. So what numbers you're going to plug in and what are you going to try to solve for. You have $10,000 to invest and you'd like $50,000 in 25 years. What should your effective annual yield be? So you're going to have to look for an investment that can give you this kind of return.
Are we looking for the entire, like,
That's a great question. I think I know what you're going. So let's see what we know and what we don't know. So what are we going to plug into the A?
50,000?
Yeah, that's the 50,000. That's the amount we want to have at the end of all of this. And the P is going to be 10,000. So we know that. Now, when we want the effective annual yield, what is that saying? Are we talking about compounding this monthly or daily or quarterly or any of that? No. So then if it's just effective annual yield we want, how many times are we compounding that? One.
So just a regular.
So that's telling you, yeah, that n is 1. Does that make sense? Okay, so then we just have the r over 1 is going to be just the r. And then the 1 times t is going to be just the t. And what is the t?
I have a question.
Yes.
So if you said that you were compound, or you had an annual interest rate of whatever, but compounded every 2 years, would it just be r over 1/2?
Oh, that's a great question. If it compounds it every 2 years, I've never heard of that. But hypothetically, if it was every 2 years, what would we do that? I think what we would have to do good question. What do you think on that, Amit? That's a good question. That's a good question. What should this be?
25.
25. Okay. You chew on that. I'm going to chew on Ronan's question there for a minute. Okay, so anyway, back to the question we can answer. We're going to divide by the 10,000, so that's going to be 5. Is that right? And how do we get rid of that pesky 25? 1/25th, so we get 1 plus r is 5 to the 1/25th power. And then we're going to subtract the 1. And what did we get as a percent then, when it's all said and done?
6.649%.
6.649%, and we have confirmation on that? All right, very good. Okay, well, excellent. If you need more examples, there is a video in the support materials section, and it works out some different examples than what you saw if you